to break. Life can be wedding cake. Get out and let it go. Up north and Mexico, everywhere can be our home. This is my life, this is your life. Anything can happen, anything can happen. We are good. Anything can happen, anything can happen. Anything can happen, anything can happen. Feeling wild, feeling free. Look at all the
Experts in treating osteoarthritis for over 25 years, Laboratoires Expanscience produced and market the osteoarthritis treatment, Piascledine 300, all over the world. Emerging from research by Laboratoires Expanscience, 98% of Piascledine 300 is a unique active ingredient based on the total extract of unsaponifiables from avocado and soybean, ASU Expanscience.
ASU Expanscience contains over 24 perfectly identified active molecules.
These
molecules belong to molecular families such as sterols and tocopherols, but also the I and H fractions that make ASU Expanscience a unique product.
ASU Expanscience has proved its effectiveness in preclinical and clinical studies to obtain drug status. To produce ASU Expanscience, the only ASU with drug status, Laboratoires Expanscience cultivate excellence at every stage of production. From the selection of raw materials to the manufacturing process of the finished product, over 15 preparatory stages and more than 50 inspections are required to guarantee the quality, safety and effectiveness of ASU Expanscience.
Our stringent standards begin with a selection of raw materials. The avocados and soybeans must pass more than 10 quality criteria. Our specifications are extremely precise with regard to their unsaponifiable content, their nature, and the proportions of the 24 molecules that characterize ASU Expanscience. This ensures that all the capsules of our finished product are identical in terms of composition and quality. Laboratoires Expanscience have been working for over 20 years with producers based in Brazil, Mexico, South Africa and Peru, where they have their own unit to keep the supply chain short and ensure responsible management.
Pioneers in plant extraction and molecular distillation, Laboratoires Expanscience use dozens of patented oil preparation and transformation processes to conserve and enrich all the active ingredients contained in the fruit.
The ASU Expanscience production process is unique, complex, and patented. It includes a concentration stage involving molecular distillation, a patented active ingredient enrichment stage, selective extraction, and a final, extremely refined purification stage to eliminate any trace of micropollutants. The process has good manufacturing certification.
Throughout the Piascledine 300 production process, a full range of precautions are taken to guarantee the safety of the product, and 30 parameters are continuously monitored. Encapsulation involves a laminar flow system, which prevents any contamination by particles when the capsules are being filled or packed. The mixture of active ingredients and excipients is heat injected into each capsule with precision to the nearest milligram. The capsules are then enclosed in a strip of gelatin to ensure a perfect seal, able to withstand variations of temperature and humidity in any region of the world. The capsules are inspected visually before joining the packing line, still in a laminar flow system. The millions of boxes of Piascledine 300 produced every year are identified before dispatch to ensure the traceability of every batch throughout the world. Over 20 million patients have benefited from the effectiveness of ASU Expanscience over more than 25 years.
Piascledine 300 significantly and dose-dependently decreases pro-inflammatory mediators like IL-6, IL-8, NO, and MMP3, an enzyme-degrading aggrecan. Piascledine 300 increases in a dose-dependent manner aggrecan production and TGF-beta1, a factor stimulating the synthesis of extracellular matrix components. Piascledine 300 normalizes sclerotic osteoblasts' metabolism by inhibiting MMP13, phosphatase alkaline, and VEGF. Further, Piascledine 300 counteracts IL-6, stimulating effects on MMP3 and VEGF. Osteoarthritis osteoblasts drastically inhibited aggrecan and type 2 collagen gene expression by osteoarthritis human chondrocytes. This inhibition was significantly more marked in the presence of sclerotic osteoblasts. Interestingly, the pre-treatment of osteoblasts with Piascledine 300 fully prevented these inhibitory effects and even induced an overproduction of type 2 collagen gene by chondrocytes. In conclusion, Piascledine 300 has beneficial effects on the metabolic changes of synovium, subchondral bone, and cartilage occurring in osteoarthritis joint. Piascledine 300 restores cartilage homeostasis by stimulating aggrecan synthesis through the release of TGF-beta1 and by reducing matrix metalloproteases production and IL-6 and IL-8 synthesis. Piascledine 300 may also control subchondral bone remodeling by decreasing the production of alkaline phosphatase and VEGF and MMP13 gene expression by osteoarthritis subchondral osteoblasts. Finally, Piascledine 300 may act on synovial membrane by decreasing the production of collagenase by synebiocyte.